power can be transferred wirelessly, without the use of cords or the modern-day power grid. It's completely possible due to the emerging technology of wireless power transfer.
Hi, I'm Chris Salerno.
And I'm Gabe Nelson.
We're here to tell you more about the emerging technology and how it will be significant in the future.
So first we'll explain the science behind the technology of wireless power transfer. On a short range, wireless power transfer relies on the concept of electromagnetic induction, where a primary coil generates a magnetic field such that a secondary coil within that field has an induced current within it. In addition, scientists have also added the concept of resonance to short-range wireless power transfer by inductance.
Resonance allows us to channel the magnetic field towards a receiver coil. Doing this increases the range of efficient power transfer.
On a long-range scale, wireless power transfer makes use of microwave beams and lasers to achieve the same results on a much longer distance level. We can convert energy into a microwave beam, which is transferred over a long distance accurately, and then can be converted back into electricity through the use of what's called a rectimeter. Lasers can also be used to transfer power over distance wirelessly. In this method, energy is converted into a laser beam, which is then sent to a destination and picked up by a solar cell, which converts the laser beam back into energy.
Yo dude, what's going on?
Oh, not much, man. How was class today?
Boring as hell as usual.
Oh, I'm sorry, dude. You want to talk about it?
Not really.
Oh, okay. Let's play video games.
Sick. In this visual example of wireless power transfer by induction, the table itself is embedded with a primary coil which produces a magnetic field on the surface, so that when the cell phone is placed on the surface or within the field, current runs in a secondary coil within the phone, charging it. Here's an example of the future potential of wireless power transfer by microwave or other long-range methods in a small neighborhood. We are demonstrating here a single, centrally located power transfer tower could replace all of the towers and underground cables and provide a blanket power supply to the entire area. In a purely hypothetical situation, some scientists believe that we could put a power emitter on the surface of the moon that would be large enough to beam power directly to Earth. Also, this could be used to power spacecraft, satellites, and other various space stations.
Alright, Chris. I'm glad you decided to join me in this open-ended discussion just about wireless power transfer in general, how it's going to impact our lifestyle, and the pros and cons of it. So, basically what we're looking at here is the ability to broadcast electricity on a long and short range, much like a radio station broadcasts music to your radio. So, how do you think this ability is going to affect our future and our lifestyles?
First of all, since the internet went wireless, people started branching out and kind of being a little bit more nomadic. So now that they won't have to be connected to like a wall or like an outlet, I think people would go even further with this.
Really? Tell me more.
Well, for one thing, one of the big possibilities that we could do is set up these towers that broadcast our little power everywhere in like third world countries, so that homes can get the power that they need without the use of wires or a really expensive infrastructure. Another way that wireless power can help us is in war. For example, we won't have to rely heavily on gasoline or diesel anymore due to the fact that we can remotely power tanks through the wireless power transfer. And one other interesting fact that could very well be a possibility is if we move on to more electric-based cars and use gas as a backup, we can power cars through this through the induction coil method when they drive over freeways or in parking lots. They'll just sit there and charge. So that way you'll never have to fill up unless it's an emergency. Do you have any other thoughts?
So as far as the pros and the cons go, we are going to lose a certain amount of energy when we wirelessly transfer all this energy, just because, no method of energy transfer is completely efficient, including the power lines we have today. But 95% efficiency rates have been achieved in preliminary testings of this technology. Also, there's a bunch of safety concerns that go along with transferring power over microwave. So naturally, having microwave beams bouncing all over the place and basically just frying people left and right isn't going to be in everybody's best health interest. So that general health issue has to be reckoned with before we can start using microwaves on a large scale to transfer power over long distances. Yet there's still a lot of potential that remains in this technology, and I think the pros do outweigh the cons.
Alright, well, thank you for having this conversation with me.
It's been a great discussion.